What are measures of dispersion? Dispersion is the state of getting dispersed or spread. Statistical dispersion means the extent to which a numerical data is likely to vary about an average value. In other words, dispersion helps to understand the distribution of the data. In statistics, the measures of dispersion help to interpret the variability of data. This is to know how much homogeneous or heterogeneous the data is. In simple terms, it shows how squeezed or scattered the variable is. Types of measures of dispersion. There are two main types of dispersion methods in statistics, which are 1. Absolute measure of dispersion. 2. Relative measure of dispersion. Absolute measure of dispersion is an dispersion contains the same unit as the original data set. Absolute dispersion method expresses the variations in terms of the average of deviations of observations like standard or mean deviations. It includes range, standard deviation, quartile deviation, and etc. There are types of absolute measures of dispersion. 1. Range. It is simply the difference between the maximum value and the minimum value given in a data set. Example below. This data is, we have here 1, 3, 5, 6, and 7. So, the maximum value is 7 minus to the minimum value, which is 1. So, the answer is 6. So, 6 is the range here. Number 2. Variance. Deduct the mean from each data in the set, then squaring each of them and adding each square, and finally dividing them by the total number of values in the data set is the variance. And below the variance, we can see the formula, variance. Number 3. Standard deviation. The square root of the variance is known as the standard deviation. So below also, we can see the formula for the standard deviation. So we have here the example for calculation of variance and standard deviation. So let's calculate the variance of the following data set: 2, 7, 3, 12, 9. The first step is to calculate the mean. The sum is 33 and there are 5 data points. Therefore, the mean is 33 divided by 5 is equal to 6.6. Then you take each value in data set, subtract the mean and square the difference. For instance, for the first value, 2 minus 6.6 squared is equals to 21.16. The next step is the square difference for all values are added. Like for example, 21.16 plus 0.16 plus 12.96 plus 29.16 plus 5.76 is equal to 69.20. The sum is then divided by the number of data points. So 69.20 divided by 5 is equal to 13.84. The variance then is 13.84. So to get the standard deviation, you calculate the square root of the variance, which is 13.84. So square root of 13.84 is equal to 3.72. So our standard deviation is 3.72. Number 4. Quartiles and quartile deviation. The quartile deviation can be defined mathematically as half of the difference between the upper and lower quartile. Here quartile deviation can be represented as QD. Q3 denoted the upper quartile and Q1 indicates the lower quartile. The quartile deviation, we can see the formula is under it. QD is equal to open Q3 minus Q1 close divided by 2. We have here example for our quartile. We have given data and the following data has 16 values. So under is we have already formula for our Q2 because Q2 is our first to find. and our Q2 value is equals to 12. Now, we're gonna find our quartile 1. Now, lower half of the data is 2, 5, 7, 7, 8, 8, 10, 10. Even number of observation. If we're just gonna follow our steps in our formula, we're just gonna find the value of our Q1. So, our value is 7.1. So, Q1 is equal to 7.5. Also, the upper half of the data is 14, 15, 17, 18, 24, 27, 28, 48. For our Q3, we're still gonna, just like what we did in our Q1 and Q2, we're still follow for the formulas for us to find the Q3. So, our Q3 is 21. Q3 is equal to 21. We already found our Q3 and Q1. So we're going to proceed for our quartile division formula, which is Q3 subtracted to Q1 divided by 2. So we already have Q3, which is 21, and our Q1 is 7.5. So 21 subtracted to 7.5 divided by 2 is equal to 6.75. Therefore, the quartile division for the given data set is 6.75. Number 5. Mean and mean deviation. The average of number is known as the mean, and the arithmetic mean of the absolute deviations of the observations from a measure of central tendency is known as the mean deviation. It also called mean absolute deviation. We have a given example here. The data set is 2, 7, 3, 12, 9. The sum of the data set is 33, and there are 5 data points. Therefore, the mean is 33 divided by 5 is equal to 6.6. Our mean deviation is 6.6. So, we have 5 types of absolute measures of dispersion, which are 1. Range, 2. Variance, 3. Standard deviation, 4. Quartile and quartile deviation, 5. Mean and mean deviation. Relative measure of dispersion. The relative measures of dispersion are used to compare the distribution of two or more data sets. These measures compares value without unit. Common relative dispersion methods include number 1. Coefficient of range. Number 2. Coefficients of variation. Number 3. Coefficients of standard deviation. Number 4. Coefficient of quartile deviation. Number 5. Coefficient of mean deviation. Coefficient of dispersion. The coefficients of dispersion are calculated along with the measures of dispersion when two series are compared that differ widely in their averages. The dispersion of coefficient is also used when two series with different measurements units are compared. It is denoted as CD. The common coefficients of dispersions are, we have our table set here. If we can see, there are formula for our coefficients of dispersion in the other table, in table 2. If we can observe, we have also a range, quartile deviation, standard deviation, and mean deviation. But in the other side, we have a different formula for when it comes for our relative measures of dispersion.
That's all for the measure of dispersion. Credits for the rightful owner of this information. Thank you so much.